So thank you everyone and welcome to the third Empowerment at Home Energy Efficiency Webinars for Change. This is a series of webinars organised by South East London Community Energy. For those of you who don't know, South East London Community Energy, or SELC for short, we're a cooperative that were founded in 2014 by a group of local people who wanted to see local action against the climate emergency. So we do a number of different things. We started off by installing solar panels on community buildings, lowering their energy bills and using any financial surplus to go towards our energy advice work. This work includes giving free, impartial and expert energy advice to anyone who's struggling to pay their energy bills. So that's a bit of an overview of us before we get in. Now I'm going to do a quick introduction of our different speakers this evening and let you know about what they do. And then they're each going to give a short presentation, and then there'll be plenty of time for questions and answers afterwards. So if you have any questions throughout, please feel free to pop them in the chat as they come up so you don't forget. And then at the end, there'll be plenty of time to go through questions and answers. Just a small housekeeping point, you are all muted at the moment. If you could please stay muted while the speakers are talking and then unmute yourself if you'd like to ask questions at the end. That would be great, thank you. So, our speakers today. First, we have Aurore Baulier. Aurore is a Part 3 architect qualified in Rennes in 2010 and a certified passive house designer. She studied for her master's in sustainable architecture in Gothenburg before working for a local architecture practices in Brittany. She's now founded her own practice, Atelier Baulier, in 2017, following experience working with Louis Vuitton in Paris and the Universal Design Studio in London. Her practice is known for designing detail-led environments using honest materials to create inspiring and beautiful permanent spatial experiences for a diverse range of clients. Aurore is also actively involved in the Architects Climate Action Network as a coordinator for the Natural Materials Group, so the perfect person to come and talk to us this evening. Next up, we'll have Chika Igwe from South East London Community Energy. Chika joined South East London Community Energy as a retrofit coordinator in 2024 as part of the Future Fit Homes team. She has a qualification up to master's level in architecture, urban design and development, and project management, with over 30 years experience in the UK and in Africa. Chika is Well AP, Well Faculty, AECB Carbon Light graduate, Prince 2 practitioner, and a Well City advisor for the International Well Building Institute. She is also a member of the Passive House Trust and the Association of Environment Conscious Buildings, and is passionate about healthy buildings. We also have Simon Ayres from Lime Green Products, who's been working with and selling lime mortars and plasters since the late 90s, when he worked as a repairer and builder on a wide range of historic buildings. With a genuine passion for quality, environmentally friendly products not readily available in the UK, he founded Lime Green Products in 2002 with his brother James. Since then, Lime Green has set about developing and manufacturing a wide range of lime-based products, everything from mortars, renders and plasters to wall insulation, which we'll hear about when Simon gives us his talk later, all of which are natural, sustainable and energy efficient. So that's our lineup of speakers, and without further ado, I'll pass over to Aurore. Thank you so much, Aurore.
Thank you. Okay, let me share. Okay, so here we go. Yes, you can all see this. Yeah. Okay, hello everyone. Thank you for Amelia.
Aurore, sorry, just to let you know, you're sharing the widescreen and not the full screen one at the moment.
No. Okay, let's try again. Sorry.
That's all right.
Is that working now?
Perfect, yeah.
Sorry about that. Okay, thank you, Amelia. And thank you everyone for joining us tonight. So I'll start with a quick introduction to ACAN, which stands for Architects Climate Action Network. It is an open voluntary network of individuals in the built environment industry. It was formed in April 2019 and has now grown into a global network of over 3,000 people. And it started with a vision for how we could work autonomously as a collective of individuals in order to make rapid decisions and respond quickly to the climate emergency. We have 3 aims, which are decarbonize now, ecological regeneration, and cultural transformation. There are 10 working groups in ACAN, and I'm a coordinator for the natural materials group. Our group is made of a team of volunteers from across industry, from architects to engineers, builders, material manufacturers, suppliers, researchers, and some homeowners as well. And so we have a very active WhatsApp group with a lot of information being shared in there, and we're meeting up online every other week. And the first task we actually embarked on was to define what is natural materials, sometimes so-called bio-based materials. So those are the 3 lines we came up with. So the natural materials are materials that are abundant or renewable with a minimal processing and therefore low embodied energy. And materials that also source responsibly with minimal ecological damage and preferably part of a regenerative land stewardship. And finally, materials that are healthy, part of a continuous life cycle, easily reusable, recycled, or returned to the earth. And here you can see a few of them. So some of them might be obvious to you, so wool, timber, but also stone and clay and quartz and straw you can see here on the bottom left. So why natural materials? So it's not just about the environment, the use of the resource and climate change. Non-toxic materials are also beneficial to everyone along the chain, from the extraction to the manufacturing, installers, occupants of the building, and eventually the people who will be in charge of dismantling a building. And health issues associated with the presence of harmful chemicals in our built environment have been now clearly identified. Some are called, for example, VOC, the volatile organic compounds, and it has been demonstrated that the chemical presence in the dwellings can actually impact the health of the inhabitants. It can be like chemicals in vinyl floors that can impact the hormone on people, but also generate respiratory issues. So understanding the carbon cycle is key to the bio-based material. So this illustration here shows you the different phases. Start with carbon storage. So when a plant grows, it actually soaks up the CO2 from the environment and they store it inside. So when they are being harvested to build a building, this carbon being sequestered. So you might hear a lot of carbon sequestration until the end of life. And using those materials can also contribute to the regenerative land management if attention is being paid to where they come from and how they've been grown, which increases the carbon capture in soil and forest. It is also important to consider the end of life of a building when designing. Waste is a huge issue in the construction industry, and therefore the choice of material is key. For example, natural timber and wood fiber insulation can be composted, which helps returning CO2 and nutrient to the soil, feeding new growth and completing the material cycle. Here we have the illustration of the carbon footprint of various insulation materials. At the top of the graph, you've got, and going towards the right, you've got material that requires a lot of processing and extraction to be made. So they are basically petroleum-based and mineral-based insulation. So the one commonly seen on site is like expanded foam materials. And then at the bottom of the graph, you see the little line going the other way. That's where carbon is being stored. Straw, for example, is brilliant in hemp, same way, because that plants that grow really fast and you can actually harvest every year in the same field potentially carbon and store it into buildings. It's worth noting as well that PIR, is like plastic foam and other petroleum-based plastic-based materials, usually end up being incinerated at the end of their life or in landfill, releasing pollutants in the environment. Looking now at retrofitting. So this is a house most of you would be quite familiar with. This is like solid masonry house in the UK. It's like solid bricks. It worth noting that all building materials before the 20th century were actually natural materials and were vapor open, relying on draft for the ventilation, keeping the building fabric healthy. And this is why when we're retrofitting, it is crucial to incorporate mechanical ventilation as part of the retrofit. So retrofit plays a huge part into improving the performance of our buildings. However, we need to take into account the fact that our buildings were built not to have any insulation, so we need to understand that to make sure we're not doing anything that is detrimental to the building fabric. And natural materials work really well with old buildings because they have that flexibility and they are vapor open. That means that they are compatible with the building fabric and not generating any damage to the existing building. Here we, on this graph, running really quickly into moisture. So back to, when we talk about indoor quality and health, actually moisture has got a big part to play. Most of you would probably think that sound control in a building is actually about keeping rain outside. However, in this illustration here, on the left, shows that actually moisture is being generated inside the building as well. It's commonly agreed that each household generates about 7 liters of water per day. That is from breathing, laundry, boiling water for pasta, a cup of tea, whatever. The graph on the right shows that there is actually an optimum relative humidity level that should be kept in a building to prevent health issues. And so managing moisture is a very important element. So it's typically done via ventilation extraction. However, the choice of materials in your building will also have an impact, and I'm going to show you how natural materials can help. In those 3 drawings, they show the same section through a thick brick wall, which has been retrofitted with vapor closed and vapor open materials. Natural materials tend to be vapor open. That means that they will allow vapor to travel through them, allowing the building fabric to dry. They also act as buffers. So if the moisture level gets too high indoor, the materials such as lime, clay, or natural fibers such as wood fiber and ship's wool would absorb the excess moisture and then releasing it when the levels have dropped. And so they do that without getting damaged, which is very important. So as you can see on the 2 drawings on the left, the vapor closed materials such as cement, plastic insulation, or plastic paint, which is worth noting that most paint, internal emulsion, are made up with 35% of plastic. Exterior excel can be up to 75% plastic. So those materials, they actually trap the moisture inside, creating issues for the building fabric, which will deteriorate over time. So this page shows a comparison between 2 retrofits of a typical masonry wall in a house, one using conventional materials and the other one using natural materials. So you can see that using natural materials doesn't mean good detailing isn't required. You can see here that all the reveal around the windows have been insulated and vapor membrane tape, and you have a continuity of the insulation. But things well done with suitable materials and a building well ventilated will ensure the longevity of the building and create a healthy, comfortable, and drop-free indoor environment. And as you can see here, plastic and vapor-closed material will tend to encourage condensation and trap moisture within the fabric. This is where we see mold growing. The draft and thermal bridging will also create cold surfaces internally, which again will foster condensation. And when we look at insulation, such as the PIR, the rigid plastic foams, these materials actually shrink over time. This means you will end up having gaps around the edges, forming thermal bypasses. So slightly springy natural materials such as hemp or wood fiber, which snugly fitted between studs, won't move and will provide a durable insulation solution. So now looking at a key graph that was released earlier in the year by the ASBP, which is the Alliance for Sustainable Building Products, which is about how much insulation you should aim for. And in this, this actually depends on your house, but the part L of the building regulation outlines a target of 0.30 watt per square meter Kelvin U value. So it's a bit technical, but basically they say that we should target this line here, but there is an allowable zone that is actually at 0.70. And when we look at the graphs that on the left, you see that's the not insulated wall, and the minute you add 20 mil, your wall installation actually the performance has doubled. And then when the sweet spot seems to be about 60 mil, where you've got a good compromise in between the performance of your wall, but also minimizing the risk of condensation on your existing masonry wall that becomes automatically a bit colder on the other side of the installation, where you might have some condensation. It's worth noting that at 60 mil of installation, you've reached 90% of the installation given by the target. And it is said that at about 40 millimeters of insulation, you save about 60% on your heating bills. Right, I tried to make that introduction quite brief, but I think it's really important to understand how and why using natural materials can help tackle the climate crisis and help being in control of our energy bills while improving the quality of our buildings. That is a project of mine that is on site at the minute, where we're insulating internally with wood fiber panels that would be rendered over with lime plaster supplied by Simon, actually. And just tell you that what we do in the natural material group, again, we actually run webinars like this one, and they're all on our YouTube channel, so you might be interested in seeing those. We are currently putting together a detailed library of using natural materials, so that should come out later in the year. We go through around university and deliver talks, and finally, if you want to join our WhatsApp group, that's the link, and that's me done slightly around a bit.
Great, thank you so much, Aurore. I can see already there are a few questions in the chat, and we'll come to those at the end once we've heard from all of our different speakers, as some of them may be answered as we go on as well. So thank you.
Thank you.
Next up, we have Simon, who's going to chat to us a bit about that wood fiber and lime in action that we saw.
Yes. Okay. Good evening, everyone. I'm Simon. Hopefully you can see this screen. There's going to be a little bit of overlap, but I don't think it helps with, we're all going to say similar things. So excuse me if you've seen some of this information before, but I'll skip on a little bit. So these sort of things we probably all know about. Some of the numbers might surprise you, but over a third of all the UK's houses are solid wall buildings. That's approximately 9 million. And as we've just learned, they're generally constructed with lime mortars and then built in a different way in general. And the building regulations say because they're built with permeable fabric, they're due special consideration, which means, in effect, that you should, although it doesn't say explicitly, you should use compatible materials, so the ones we've just been learning about, the natural materials, irrespective of whether you think natural materials because of low VOCs and all the other things are good for you, they are also technically the right thing according to the government's best practice guide and Part L for dealing with those solid wall buildings. And as it says there's an awful lot of carbon dioxide emitted from those buildings, and as many of you probably don't know, they are cold and damp and difficult to heat. So going on to a little bit more of the nuts and bolts of designing internal and external wall insulation. Obviously the considerations are normally, if you can fit external insulation, it's a better thing. So external insulation, if you think, goes on the outside of your walls and envelops the house like a tea cozy, and thereby gives you a better thermal performance for the same thickness of insulation, because you have fewer thermal bridges. I'll come on to that in a moment. So you've got to weigh up different things when deciding which one to do. So thermal performance obviously is important. How much space you're going to lose inside or out, how much space can you use? And then particularly with internal insulation, the risks, and the risks are principally to do with internal insulation and principally to do with moisture. Okay, as we've just been learning, where does the moisture come from? Does the insulation material we are using trap it, or does it allow it to breathe out, and those sort of things? So there are the three guiding principles. So why insulate externally? As I've just said, I'm doing this in reverse, so excuse me. It's technically superior. So thermal bridges are the bits of wall which are difficult to insulate and which you can lose heat through. So it's so it might be if your neighbour isn't insulated and you're semi-detached, it might be leaking a bit of heat through the gap. Join with your neighbour. Another reason why externalization is good for some people is because there's no loss of space on the inside. It also lowers the condensation risk or the moisture within the wall. That's because you've kind of got a new weatherproof front over your building. And it improves so if you've got an old building that needs improvement from the protection against the weather, it offers a good thing. Though it can be difficult to do because of the building might be listed, or it might be in a conservation area, or there might be complex detailing. So you might have bay windows, decorative brickwork that you might want to keep, other features which make it difficult to add in external insulation, window sills, and so on and so forth. All those sort of things might be difficult to overcome. Insulating internally, I'm going to do it in reverse again. So obviously you get to keep the external appearance of the property. It's generally a bit cheaper. And also that can be cheaper, and you can do it piecemeal, so you can do it room by room, whereas external you need to kind of do in at least one elevation at a time. There are, this might be slightly controversial, fewer specialist skills perhaps, because externally you need more people on site, more labour to do rendering in one swoop, so you get the whole thing done in one go. Whereas internally, you can be a little bit more piecemeal. You can have one or two people rather than a whole team. Problems with internal insulation. Again, you've got detailing. So have you got decorative mouldings? Is it a Victorian property with decorative mouldings that you want to keep? Is the building made up of lots of additions over time, which make junctions difficult, that sort of thing? It's definitely riskier from a condensation point of view. So water vapor, as it goes through the wall, will condense and turn to liquid water. That liquid water is not a good thing around timber that will be embedded in the wall. And because you can't insulate the whole of the wall quite like you can with external insulation, it's not quite as thermally efficient because you've got thermal bridges, particularly windows, particularly internal partition walls and that sort of thing, and you lose some space. But remember, it's about 50 millimeters upwards from. You may have two external walls, but you wouldn't normally have three, so it might be a little bit of space. And there's a picture of some external insulation. I'll move on quickly because I realise we haven't got lots of time. Types of insulation, kind of been through this a little bit already. You've got your petrochemical, extruded, expanded type, mineral wool, foam glass, that sort of thing. Natural, as we just learned, wood fibre, flexible, rigid, straw, sheep's wool, and so on and so forth, hempcrete, and that sort of thing. We choose our materials on technical performance, as well as going with the ASBP, and there's a link there at the bottom to the ASBP, who have 6 pillars of sustainable construction. It's a little bit like the ACAN philosophy about not just choosing materials on, say, if it's an insulation material, just on the thermal performance alone. You choose it on all the other performances, technical, ethical, and all that kind of stuff. And this is why, because we don't think insulation provides just one role. We think insulation provides multiple roles, 8 in fact: thermal, acoustic. So there are studies that are gaining more and more studies now for the background noise in buildings and how that affects people's health. And it has a significant effect on people's health in noisy environments. So acoustic is really important. Fire protection, naturally. Health, of course. So again, go back to VOCs and those sort of materials. You know, what is the material made from and what's it off gas or otherwise? Comfort. So it's slightly difficult to put numbers or figures on, but it's a combination of things like thermal, acoustic, moisture, that sort of thing. Buildability, how easy is it to use? Durability, we want materials to be durable and long lasting, done correctly. Some of the measures I'll show you in a moment are good for 25 years upwards easily, and sustainable, of course. So they need to be, if we're using wood fiber, obviously it's something you can grow and it's from sustainable forests, that sort of stuff. So natural insulations are moisture. So we use wood fiber principally in our insulation systems, and that means they are breathable and moisture buffering. Not quite the same thing, but breathable is allowing water vapor to escape through a material. Moisture buffering is a insulation that might, sheep's wool is particularly good at this, and denser wood fiber. So it will be unaffected, its thermal performance will be unaffected at times of higher moisture loading, whereas other insulations really don't. Natural insulations also are very good with summer heat protection as well. So if you've ever been in an attic space that has been retrofitted and you use some more commonplace, more modern, well, not modern, but commonplace petrochemical or mineral wool insulations, that you can overheat in the attic space quite quickly, whereas wood fiber doesn't. Of course, it also locks up carbon, which is a really important thing. Very quick pyramid. It's a little bit like Aurore's one from earlier, but this is to achieve the same thermal performance. Which materials give off the most CO2 in their production? And you can see there, of course, the natural materials, wood fiber, straw, and so are right at the bottom, and right at the top are the ones we'd expect to be there. So I'll just very quickly run through a few projects and just how the systems go together. So all the systems that we provide are given a lime plaster or lime render over the top to protect them. That lime render and lime plaster protects against impact resistance, the weather if it's external, fire if it's external, and fire if it's inside, and obviously gives a surface to decorate it. So here we've got a project in Lambeth, and the building to the right is 2 new passive houses, and the building to the left is a retrofit Victorian property that has had internal insulation, and it's perfectly possible to mix and match internal and external on the same property. That's acceptable, and it's quite often for external insulation to go on the rear of a property, retain the perhaps Victorian facade on the front or what have you, and have internal insulation. So internal insulation, with our system, other systems are different, but our system is composed of 4 components and is the type of system that's the least risky according to the government's best practice guide for upgrading in solid wall buildings. You may need it, or you may not, but there's a leveling plaster goes on the wall, so there may already be one there. Then the boards are fitted as on the right. They're fitted to the walls. You've got a nice new flat surface that's insulated. There are no gaps The boards are interlocking. They've got a tongue and groove, so it's really tight. No gaps, no junctions, that sort of thing. Any junctions with windows and doors, boards must be fitted tight. Insulation around the window reveals and between the floor zones. Windows up, plastered right up to the window and doors, so that that's the coolest bit of the wall, and it needs to be given really good attention. We always say the detailing with internal wall insulation and external is really important. You might think adding a great big thick layer of insulation to your wall in general would be a good thing, but if you ignore the detailing, the floor zone, the window and door reveals, the bits that lead up to the window and doors, then you are effectively wasting your efforts with that big thick slab of insulation on the main part of the wall, because the other bits will drag it back down and really reduce your efforts. Here's slightly more. Again, it's a Victorian property with an extension, and this is been lime plastered and left unpainted. So it's slightly more modern take on it. Lime plaster doesn't have to look old and weird. It can look, as in the last photograph, it can look just like normal plaster. It's perfectly easy to use. We've designed products which are designed to be used by normal plasterers rather than specialists. And as I say, there's only 4 components. Externally, slightly different, similar number of components, but the boards are fitted to the walls again in a sort of brick bond pattern. Boards, these are wood fiber boards, they're cut just like any other insulation, perhaps with working tools and saws and that sort of thing. Externally, there are specific fixings that clamp the boards to the wall. And then there is a render system that goes over the top. We've got an undercoat with a reinforcing mesh, and that's the orange product at the top right. That's given another layer over the top, allowed to go off, and then finally coated with a lime render or a similar sort of products over the top to protect it against the weather. And that is about me. Finished. Race through that quick as I can.
Thank you so much, Simon. Thank you for that. We have Chika up next, who's going to talk us through a bit about the health benefits and how to plan for using natural materials in your retrofit journey.
Great. Hello, everyone. Just like Simon said, there's going to be quite some overlapping, but I'm just going to very quickly skim over the reason at Future Fit Homes we prefer and we choose to use nature-based materials for improving the energy efficiency of homes, particularly for their health benefits, and I'll give the reasons why. So here is making a case for healthy buildings. And in this diagram, you can see right at the center, issues to avoid. And the reason we use nature-based materials will be really to just take care of the issues in the middle sector of this diagram. Now, it's actually the concentric circles are actually split in 2, but overwhelmingly on the left-hand side are issues that affect health, occupant health and comfort, whilst on the other side, that's on the right-hand side, are issues that affect building health. And you can see it's disproportionately much more on the occupant health of users. An example of one of the issues will be like overheating, and the outermost ring shows, for instance, the outcome of that or effect of that. There could be heat stroke, especially on elderly occupants, or people who have health challenges already. Cold is another one. It could lead to heart problems, hypothermia, etc. Moisture, I mean, you've heard a lot about moisture, and also mold. All these ones have effects on the respiratory system. They could trigger asthma, they could cause lung issues. Also, poor ventilation is another thing which can also trigger these, as well as allergies. Then you also have droughts and cold spots. Simon mentioned thermal bypass, so you have cold spots in the house where, for instance, corners or joints where there's not enough or draft proofing, and these could lead to sick days, loss of income, and generally, feeling unwell. So that's the main reason why I would like to focus on nature-based materials, basically, to address these issues that affect the health of the occupant. This shows really different building types in the UK and how the building structure itself can actually affect the heating demand of those homes. It also has to do with sorry, I'm just gonna adjust this here. It also has to do with how the age of the properties, like for instance, the Edwardian homes built around the 1910s and thereabout. Those homes, generally, we acknowledge that they are leakier than, for instance, the new house built in the 1990s, for instance. And this other graph, this other chart here shows that overwhelmingly that the space heating, basically the energy used in a domestic property is predominantly to heat up the place. So what we try to do, or what we hope to do with in future fit homes, is to reduce the space demand drastically, and we find that nature-based materials do that excellently. You've heard that from the previous speakers. This shows the heat losses by building elements for a typical building, and just at a glance, you can see that the highest is heat loss from the walls, and obviously the next bit, the roof, and then the floor. This is, I mean, heat losses from the walls and the roof basically are usually from conduction. I mean, they're called the fabric losses, and they're usually from conduction from the heat losses through the external elements of the buildings through the wall by conduction. Then there are ventilation losses that we can get through the windows. You can get from droughts through the edges, corners, especially if they're not joined well. So what do we do? At Future Fit Homes, we believe in a whole house approach. Now, what that means is that it just ensures that from the onset, every aspect of the building structure and how they interact with one another over time are considered and taken into consideration to produce a phased plan. Then we say fabric first. The fabric first approach ensures that at Future Fit Homes, we tackle the biggest issues, like we had identified in the previous slide, that it's really losing heat through the external structure, through the fabric. And then finally, we actually, at the heart of what we do, consider the current and future users. So that will be like, for instance, how many people in the house, how many people are expected in the house, as in future, like, for instance, if it's a young couple and they're expecting to have more children, We also look at things like culture, because that will affect, for instance, how the houses are used. So in places where, for instance, there's a lot of gathering in the living spaces, maybe because of the culture, we make sure that we address those, or we take them into consideration. Here we're looking at nature-based materials and health, and we're just going to focus on just four aspects. Looking at the air, for instance, nature-based materials like wood fiber that has been mentioned for insulation, they're known to improve the indoor air quality and reduce off-gassing of like furniture or the insulation material itself, for instance. They're also good at absorbing as well carbon dioxide. And I think Simon mentioned the relative humidity, the optimal relative humidity in a building. That is also important in terms of the indoor air quality. In terms of heat, natural nature-based materials are excellent. They're really excellent in regulating the thermal comfort, and they actually do this in two ways. Because one, they're breathable. So just like Simon mentioned, they're vapor open, so they allow moisture to move in and out easily and be able to dry out instead of basically staying locked in. And when we have issues of where, for instance, we use non-nature-based materials, like for insulation, for instance, and they're not vapor open, what happens is that these moisture can get behind or dip into the materials, so that behind the insulation, you start having condensation and mold happen there. Then sound. Nature-based materials are brilliant with absorbing sound, impact-borne sound, airborne sound. Just like Simon mentioned, it's been proven that it can actually, dampen. It dampens noise. For retrofitting a property that is on a high street, for instance, maybe in a conservation area, you can't afford, for instance, to open to have air vents in the windows and all that. Having a nature-based insulation as IWI, that's internal wall insulation, can help a lot, for instance, with dampening the sounds that would normally come in through the windows or even the vents, for instance. Then finally will be mind. Looking at nature-based materials as improving or enhancing well-being, in the sense that because it dampens sounds, it modulates the environment, the indoor, and then makes for good indoor air quality. The ambient environment is good, and is desirable, and that generally, I think, keeps people less stressed. And I'm looking at the time, I'll just round up very quickly. And of course, because heating demand is reduced, costs are reduced as well, which means there'll be savings. If there are fewer instances of, for instance, having colds or flus in a cold property, that also reduces time wasted, time lost to not working, or loss of earnings. So generally, it helps with well-being. So finally, what we offer at Future Fit Homes, firstly, we do listen to you. So we invite you to reach out to us, give us an idea of what what your goals are. So we both agree with you on your goals. Then we send our retrofit assessors to your home, who would do a thorough investigation of what exists in your home. That is very important because it's going to be the basis for a bespoke whole house plan that we'll provide. We can also help you with, implementing that plan, matching you with installers, such as, for instance, the other speaker, Simon, and his company, and also verify performance and monitor success if that is part of our engagement. Thank you very much for listening. And if you'd like to explore more of how we can help you become healthier in your home, make your home healthier and make it healthier for the planet, please do get in touch. Thank you.
Great. Thank you so much, Chika. I just wanted to highlight that Future Fit Homes is the retrofit arm of South East London Community Energy. So it's part of the cooperative, and it's our vision of supporting South East Londoners to make their homes fit for the future. So it's open to people who are living in Lewisham, Greenwich, Lambeth or Newham. So feel free to get in touch with us if you want. So we're at 7:50. I'm going to open up to some questions. We have a couple in the chat, and I'm just going to have a look here. For some reason, the chat has disappeared for me. Or if anybody wants to put their hand up and ask the panel directly if they had a question directly for anyone. But I'm just looking at the chat now, and there was one that was asking about the first person that had asked what the best natural materials were for cavity wall instead of polystyrene beads. So I don't know if any of our panel necessarily want to jump up and answer that. Aurora, do you have any experience of using any natural materials in cavity walls?
Well, the first thing to say is actually we should be really careful with insulating cavity walls. If you're not doing anything externally, if you're not insulating externally, you should not put insulation cavity, because the cavity is there for a reason. It's to drain rainwater that might have gotten through the first leaf of brick. So if you put insulation there, the moisture will be eventually transferred to the inner leaf, and the moisture will get into your house. So if you're not doing anything to the external leaf, as in somewhat putting external insulation and a lime render on top, then you should really not be putting insulation inside the cavity. That said, if you've done the external insulation, I'm not too sure, actually. I have never had experience. I think you might be able to put some core granules and something like that in the cavity, but I think usually it's quite a tricky one. I don't know if Simon's got some experience on that.
No, I don't know that much about it either, but there are alternatives to the usual expanded polystyrene. I think, yeah, cork might be one. I think foamed glass beads might be another. There is mineral wool, but it's not natural materials. Foamed glass is not exactly natural, but it is often recycled. But
there's perlite, maybe perlite as well, which is used for to insulate chimney flues. So it's like an expanded mineral.
Yeah,
it's a tricky one.
Great, thank you. There was another question asking how fireproof or waterproof these materials were. And if there's any risk of getting wet if a wall cracked. I know you spoke about the thermal conductivity was not impacted in some of the natural materials by getting wet. So that somewhat answers that, but fireproofness, I wonder if anyone could speak to that.
Yes, so natural materials in general have a similar fire resistance to most petrochemical based products. Okay, so if it's, for instance, wood fiber, for instance, whether it's flexible or rigid, it's very similar to other products. But importantly, they don't contain fire retardants and that sort of thing, which do eventually, when they do eventually burn, give off unpleasant gases. So they are they're similar, all the same. But the important thing is to look out for the system performance. So it's the system that gives you the result rather than an individual component. So if you're installing external or internal installation, it will be the system that will have had a fire test. And as long as it's a, reputable manufacturer and it's been through that fire testing process, then it's going to give you a result. And if that fits in with the building regulations, then it's all good.
Great, thank you for that. I'm going to take one more just before we wrap up, which is asking if using natural materials, if mechanical ventilation is still necessary, because that was spoke about something that was needed to be looked into when adding insulation.
No, you want to go? I mean, I would say yes. You need ventilation. I don't know if Chika would have another answer.
Yeah, I do agree. Once you insulate, what you're doing is you've actually just sort of like changed the moisture balance internally. So you have to also address ventilation. So at the very least, there should be some kind of passive ventilation, but most times you would need some mechanical ventilation, at least in the wet rooms. And I just also wanted to just add to what Simon said about fire qualities of nature-based materials, to say that cork is an exceptional one. It does have very good fire resistant qualities. That's why, for instance, you'd see a cork tree go through forest fire, and the cork is wrapped, basically protecting the rest of the trunk of the tree. So naturally, cork does have very good fire resisting qualities.
Great, thank you. We're running over slightly, so I'm gonna bring us to a close on that, but I wanted to thank you all so much for your insight. And just say that, as I mentioned at the beginning, this is part of a monthly series of empowerment at home, energy efficiency webinars for change. We're taking a break over August, but we'll be back in September, and we're always looking for speakers and ideas. If there's something that you would like to see a webinar hosted on, if there are particular topics, one of the next ones we're planning will be on heat pumps. So if there's anything particular people would like to hear about, please get in touch with us. You can find our contact details through Eventbrite. So thank you so much, and thank you to all of our speakers, and apologies we're running over. So have a lovely evening, everyone.
Thank you very much.
Thank you.